Hello everybody! Today we're going to be looking at two different concepts, area and volume. These are things that we measure using the skills that you learned in the last lecture, and our objective for today is that you're going to be able to find the volume and surface area of rectangular prisms and cylinders. Now, one concept that comes up very frequently in this is the difference between 2 dimensions and 3 dimensions. So for instance, I might have a 2-dimensional square right here. It's flat. It doesn't have any depth to it. But if I all of a sudden add, let's do this in blue, if I add a third dimension to it, now all of a sudden I have changed my square and turned it into a cube. This one side of it is the same as the square, but now it has a depth to it. And that's going to be something you need to pay attention to as we're dealing with different shapes. So the vocabulary for today, we're going to be dealing with the concept of area, which is symbolized by a capital A, the circumference, which is a capital C, cylinders, surface area, diameter, which is a lowercase d, pi, which has its own symbol, radius, which is a lowercase r, and volume, which is a capital V. So let's go ahead and get started with squares and rectangles. For a square, the math is really easy because the length and the width are exactly the same. Now, I'm going to introduce you now to the concept of area. The area is the amount of square units that are covered by a shape or a figure. I want you to kind of place this object on a grid, or for those of you who are more video game inclined, think of it like kind of like Minecraft. If I have a square right here and my grid is placed like this, I can figure out how many units this square is covering up using the equation for area. Now, it's worth noting that in a square, my length and my width are exactly equal, so I know that if I have 2 units as a length, I also have 2 units as a width. So the area of my square, being length times width, is 2 times 2, which is equal to 4. There are 4 units being covered up by this square. Now, for a rectangle, we're not quite so lucky because the length and the width are not equal. But we still use the same equation. We're still dealing with this concept of length times width for rectangles as well, but you just have to know the differences in the sides for a rectangle. Now, a cube is an entirely different beast because now all of a sudden we have added width to it. So with a three-dimensional object, we're dealing with a couple different ideas. The first one is surface area, the total area of the faces or curved surface of a solid figure. If you want me to put this in very simple terms, surface area is if you had like a wooden block, it's the amount of stuff that you can touch on the outside. You can't obviously get at the wood that is in the middle of the block without destroying it, but you've got 6 different faces of that block, and that's the surface areas, the things that are showing up on the outside. Now, the volume is the total amount of space that that block takes up. It is the capacity that you could fill it to, or the amount that can be contained inside of an object. So just think of it in a three-dimensional world, it's the amount of space taken up by something. Now, the surface area for a cube is going to be 6 times length times width. And why this is because in a cube, while we're dealing with the perfectly equal sides, you can see right here, I will draw myself this lovely little square here. This is one side of my square, and I know that length times width, and they are equal. So if I say this is a side of 2 and this is a side of 2, I have an area of 4 here. And I know that I also have 6 exactly the same sides on the outside of this cube. So if I go ahead and take 4 times 6, I'm going to have a surface area of 24 units. Now that's the surface area. In order to find the volume, the math gets a little bit easier. We have length times width times height that we're dealing with now. So if I have a length of 2, a width of 2, and a height of 2, I'm going to go ahead and put that in there. Now we're just dealing with 2 times 2 times 2, and so we should wind up with 8 units of volume. Now, these are different units. We're not saying that there's more space on the outside than the total cube comes up with, and I'll discuss that in just a minute. But cubes have the same length, width, and height. Rectangular prisms do not, and this is where things get a little bit more tricky. With a rectangular prism, you're dealing with different sides of things. So I can still find the area of this square right here, this rectangle, I should say. It's got a defined area. I can take length times width. I can figure that out. Now, if you think about it, I know there's an exact same side that looks just like this on the other side. It's somewhere over on this other side of the image that you can't see. So I know I have two of these. I also have two of this top section. I have two of this side. I have two of the bottom section. So if you take 2 times width times height, 2 times width times length, and 2 times length times height, and you add all of this nonsense up, you will find the surface area of your rectangular prism. It gets a little complicated, but it's not really that bad. It makes sense when you actually start to think about it. Now, lucky for you, the volume of a rectangle is significantly easier to calculate because once again, all we need to know is length times width times height. These are very easy to figure out. But unfortunately for us, not everything has a defined beginning or an end or defined sides because we're going to be dealing with circles quite a bit. Now, circles have a variety of different concepts that we have to deal with. The first one being circumference, the distance around a circle. The circumference is what happens if I start measuring at one point in a circle and I go all the way around, all the way back to where I began. This would be the circumference of a circle. And that's somewhat useful, but often what we take a look at more is the ideas of diameter and radius. A diameter is what happens if I was to cut straight across my circle. This is my diameter, and that's somewhat useful, but radius is the one you're going to take use to the most. If you think about it this way, if I was to tie a piece of string to a pencil and put that pencil in the middle of the desk, and you stretch the string out as far as you can, and then rotated it all the way around the pencil, that string, if it is stretched the whole time, is going to be the same distance from any point in that circle that you just created to the middle. So the radius is the distance from the center to any point on the circle. And the radius is very useful when we start doing calculations. The calculations you guys need to know for the circles are these ones: that the diameter is 2 times the radius, that the radius is half of the diameter. You guys will need to know that pi is equal to 3.14. I'm not going to hold you to any more digits than that. Area is pi r squared, and circumference is 2 pi r. Now, as you guys are finishing that up, let's go ahead and take a practice shot at this. Find the area of this circle if I give you that the radius is 5. Now, the first thing you need to figure out is what equation are we going to use. So that one's pretty simple. The area of the circle is pi r squared. Now, r is our radius. So I wind up with having pi times 5 times 5, r squared. So it's pi times 25. And our answer for this one is going to be, oops, I actually drew over it. It's actually 78.5 inches, I'll erase that, squared. So 78.5 inches squared, that's going to be the area of this circle. So go ahead and now take a moment, find the circumference of this circle. Remember that our equation for this is 2 pi r, so we are going to take pi times the radius and simply double it. And what you should come out to is 31.415. So this would be the area completely around the circle. Now, a cylinder is simply a circle that has a height to it, so we're going to be using the base area, which we found out is pi r squared, times the height. So that's not so bad. And I'll let you guys find the volume of this one. Go ahead and pause it right now, work this one out on your own. What you should wind up getting is 3,562.6 inches cubed. And coming to our last point, why is area squared and volume is cubed? Because area deals with a 2-dimensional plane and volume is always a 3 dimensions. And those are the big ones. In summary, we dealt with the difference between squares and cubes. and we figured out how to calculate both the surface area and the volume of those shapes. Thank you for watching.